Hey guys, welcome. This is our dilation video. I found this kind of cool little math notebook thing. So I've got this cool math website here, MathBits Notebook Geometry, so I thought we'd try this out and see how it works. Kind of cool. So dilations are enlargements, where you're getting something larger, or a reduction, getting something smaller. And so we're just going to have you write down the stuff that I underline. How about that? Okay, so a dilation is a transformation that produces an image that is the same shape as the original, but it's a different size. Okay, dilation that creates a larger image is called an enlargement, and a dilation that creates a smaller image is called a reduction. So we're going to go ahead and write all of that down. Okay, here's a nice little perspective of how this would work. From a point O, normally we would use the origin. AB would go under a, in this case, enlargement to the transformed shape here. A prime, B prime, C prime, and it has gotten bigger by some sort of factor. A description of a dilation includes the scale factor and the center of dilation. In this class, we're always going to be dilating around the origin. So the scale factor and our center of dilation is a fixed point. If the scale factor is greater than 1, the image is enlarged, it expands. If it's between 0 and 1, it is a reduction. That would be like a fraction, like 1/2, 1/3, 1/5. And if the scale factor is 1, the figure and the image don't change, don't move. And we're going to go ahead and write all of that down. Okay, so pause the video, write those down. Moving on. Okay. Okay, the word dilate is often heard in relation to the human eye. The pupils of the eye were dilated. We talked about that, turning on and off the switch in the bathroom as you're staring in the light. We also see it in a variety of situations. Photography, we might enlarge things. Russian dolls, which are really common, everyone has them. Graphing calculators, we can enlarge and shrink the screen size. Food services, supersize me, what's up? Logos on a pizza box, they have different sizes, but you can enlarge them. And toys that grow. It's a really weird thing that they would mention, but anyways, I don't think that's a very common thing. I like the logos one. Pizza shop boxes. I used to work at a pizza place. It was fun. And I got a lot of pizza. Alright, we're going to do 2 example problems right here, so you don't have to write any of that stuff up there. But it says dilation in the coordinate plane. Most dilation in the coordinate plane will be using the origin, which we will be doing, as the center of the dilation. The center of the dilation will be indicated within the problem. Okay, so here's our problem here. The dilation of a scale factor 2. So we have our original quadrant points right here of 0, 2, 2, -1, -2, 2. So we start with ABC, and we draw the dilation image of the triangle at the center of the origin and a scale factor of 2. So we go ahead and we just multiply everything. Here's the rule right here. Everything's just getting multiplied by 2. So 0, 2 becomes 0, 4. 2, -1 becomes 4, -2. And -2, -2 becomes -4, -4. And all you have to do is multiplication. I'd like you to draw this whole thing right here. Yeah, I know. It's crazy. But picture, write, and rule. Okay? Let's do one last one. And right here, dilation scale factor at 1/2. And yes, you are going to be writing all of this down. Okay? Same thing we're doing, we're multiplying, but we're multiplying by 1/2, which means it's going to get smaller. So our original figure is the blue shape here. And we're going to get smaller, so we're going from -2, 4 down to -1 and 2. Okay, so we go ahead and multiply by 1/2, which actually reduces the size. And that's it. So we basically have scale factors for dilation, and if we have a number bigger than 1, it's going to enlarge from 0 to 1, 0 to 1, 0 to 1 like this, I guess, I don't know. Then it's going to get smaller, like a fraction, and if it's 1, it'll just stay the same. Okay? Alright, hasta luego, and goodbye.